Good morning, good afternoon, good evening, mammals, whenever you guys happen to be watching this. This is going to be for NTI number 4, Monday, March the 16th. I hope you guys are doing well, and in this first one, we are going to be looking at some of the slides that I posted for your acid titration lab report. We're going to be skipping over the introduction for right now because the first thing that I want you guys working on is the calculations. So expect a video coming up for later NTIs which will deal with my guidelines for writing this and your conclusion. But for right now, I'm going to skip on over to the next, talking about kind of the meat of it, what needs to go into your introduction slide, and talk to you about the calculations that you need to do. There's really only two calculations that you're going to do for each of the acids, the white and the blue, and that is determining the concentration and calculating your percent error. The only data points that you need right now are the volume of the acid that you used. Remember, we're treating this basically as water because they were really dilute. So whatever mass of acid that you used is going to be the volume in milliliters. So if you need to subtract off the weight of the empty cup to get that, or if you zeroed out the cup, whatever it was, the mass of acid that you added, we're going to treat as the volume. And the other data point that you need for today's calculation is the volume at the equivalence point. The pH values that you recorded with the pH paper, you don't need that for an actual calculation. We'll deal with that in the future. But for right now, I want to deal with, walk you through a sample calculation to get the concentrations and the percent errors. So bear with me as I remember kind of how to play with this program, and hopefully I'll get better as we go on. So scooch that up out of the way. So let's imagine we've got a titration curve, and on this axis is going to be our volume of base that we added. And we of course didn't get a nice smooth titration line like this with the the pH, but instead we've just got points along this curve. But that doesn't really matter because what we do have is we do have the equivalence point. And we got that because after this point, our solution would have turned pink, whereas before it was clear. And so that was how we determined the equivalence point. And so you're going to record the volume at this point, and that's the volume that we need. Scoot this out of the way. So let's say that your equivalence point volume, just to be easy, was 30 milliliters. So we've got 0.03 liters of NaOH. The concentration of everybody's NaOH was 0.1 molar. So 0.1 moles per liter. So at this point, I have how many moles of base I added. The handy thing about this is in a titration curve, moles base added is equal to moles acid that were initially present. So here we go. So I'm going to take this, and that's going to give me 0.003 moles base, which means 0.003 moles of acid. Now to get the concentration, I just need to divide my moles by the volume that I use. So let's say that you use 25 milliliters of acid. So 0.003 moles over 0.025 liters. That gets us moles over liters. So that's our concentration. Pulling my calculator out. So I would get a concentration of 0.12 molar for this made up example. The last step is the percent error, which is always your experimental value minus the accepted value over the accepted times 100. Now in our case, both of the acids, the accepted values were 0.01 molar. So for my example here, it would be 0.12 minus 0.1 over 0.1 times 100. So in my example here, I would have a 20% error. And then you would just repeat this same calculation for the other acid. So the calculation part shouldn't take you too long. Just take your volume of base at the equivalence point, multiply it by 0.1, get you your moles of base, which is the same as your moles of acid, divide by the volume of acid, and you've got your concentration. So that's that part. And then do experimental minus accepted over accepted to get your percent error. And that's that part. And just repeat that for the other acid. So this really should be about 5 minutes of working. What you could be doing, some of the other stuff, so that you can be a little more productive if you want to get ahead, would be going on and getting this into a nice table. I'll go ahead and post the assignment with the Google Doc for you to start putting in kind of like the thoughtless stuff, writing up your procedure, getting your data and this into a nice chart. And then my video tomorrow will include and then what needs to go into your conclusion. So I hope you guys find this helpful. If you have any other questions, post in the Google Classroom comments, and take care of yourself and others, practice good hygiene, and we'll talk to you on the flip side.